Page 3 of descriptive statistics. First is a problem that's a continuation of the last page. A plant inspector takes a random sample of 6-month-old seedlings from a nursery, measures their height to the nearest millimeter. The results are shown in the frequency histogram. How many of the seedlings are 400 millimeters or more in height? Let's see, 400 millimeters. That would be there, right? So how many are more than 400? It would be this part here. So let's see, that's this would be about 14 maybe, and this would be about 6 maybe, so about 20, right? About 20. What percentage of the seedlings are between 349 and 400? 349 and 400. So that would be about 349 would be about here, and 400 is here. So it would be like this area. Now it says what percentage of the seedlings. So first we need to figure out how many seedlings. It would be about 43 maybe. And this would be about 27, 28 maybe. So 28 plus 43, 28, 43, that would be about 71. So about 71 seedlings. Now to see what percentage of the seedlings is 71, we would have to know the total number of seedlings, which we would need to count all these frequencies and add them all up. Let me do that really quick. So I estimated the height of each one of these, and I wrote it in blue here. I added them all up. I got 121 total samples. So the percentage would be 71 divided by 121. I'll put that here. 71 divided by 121. So let's do that with the calculator. 71 divided by 121 to get a percentage. It's 58.7%. 58.7%. Okay. And then the total number of seedlings in the nursery is actually 1,462. Estimate the number of seedlings which measure less than 400. Okay, so we found out that there are 20 seedlings in the sample that are 400 millimeters or more. So, and what percentage would that be? That would be about 20 divided by 121, which would be 16.5%. So how many seedlings would be less than 400 millimeters? That would be the opposite of 16.5%. So that would be 1 minus 16.5%, which would be 83.5%. So the number of seedlings that would be less than 400 would be 83.5% of 1,462, which is the total number of seedlings, not the sample, but the total number. So that would be 1462. It would be 1,220 about. Okay, what about seedlings that measure between 374 and 425? So 374 and 425 would be from here to here. So according to the samples, that would be 28 plus 14 seedlings, which is about 42 total. So the proportion is 42 divided by 121, which is the number of samples of the number of the percentage of samples. So 42 divided by 121. Let's see what percentage that is. 34.7%. Okay, and then we want to see what 34.7% is of the total sample, of the total nursery size, which is 1462, and then we will get the estimated number of seedlings, which measure between these two. It's about 507. Okay, so here's the answer to this one, and here's the answer to this one. Okay. All right. Then we start on 20B, measuring the center of data. Below are statistics that measure the center of the data set. It's kind of like saying the typical value of the data set. So what are the names for these different measures of center? Sum of all data values divided by the number of data values, that is known as mean or average. Middle value of a data set, that would be median. For discrete data, the value of the data set that occurs most frequently, that's the mode. For continuous data, the data class or group that occurs most frequently, that would be the modal class. So if you remember, the difference between discrete data and continuous data is the continuous data is like the decimal data that you probably don't get repeated numbers. Normally we classify those into groups or classes, like we say, oh, all the measurements between 30 and 40, all the measurements between 40 and 50, etc. So when you do that, then you don't have a single mode anymore. What you have is one of the groups or classes which occurs most frequently. Instead of calling that a mode, we call it a modal class. Okay. X bar, written X bar, represents the mean of a sample. Written as the Greek M, it looks kind of like that, represents the mean of a population. So what's the difference between a population and a sample? A population is everybody you're looking at. A sample would be the people that you can practically choose and count and figure out characteristics of your data set. So normally you can't do that with every single person. That would be more like a census, which we talked about before. Median is the middle value of the data set. I kind of messed up here. I didn't mean to talk about mode here. I meant median. Median is the middle value of the data set. What do you do if there is no middle value because the number of data is even? So what you do then is you just take the two values that are surrounding the middle, and then you would you would average those. So take the two values around the middle and take the mean of those. That would be the median in this case. Okay. What statistics do you think is a good indicator of measure of center, and why? Which statistic do you think is a bad indicator of measure of center, and why? This is your opinion. So you tell me between mean, median, mode, what you've used in the past for science fair and other things. Why did you choose that one? What were the reasons why you did not choose another one? Okay? The median is considered a resistant measure of center because it's called resistant measure of center because extreme values, like maybe that might be outliers at the left and the right of the distribution, will not affect the median, where they do affect the mean. Okay, so we'll write that because extreme values do not affect the value of the median. Okay. Next one. Mean and median will be the same if the distribution is what we call symmetrical. Okay, does that make sense? The middle value and the mean, which is kind of a middle value, it kind of takes the weight of every single point and it adds them together and takes the middle one of that. will be the same if the distribution is symmetrical, right? Okay. So sketch to the right an example where mean and median are the same, but mode is not the same. Remember, mode is like the high point of the graph. And so like normally you think of a symmetrical distribution graph kind of like that. And in this case, the mode is here, the mean is there, and the median is there because it's symmetrical. Now, how would you have a distribution where mean and mode are in the center, but mean and median are in the center, but mode is not? So that would be something like this. Okay, so if you had a symmetrical, but you did not have the high point in the middle, then the mode is going to be kind of like these 2 points here. So in that case, we're looking at something like that. All right. Number 1, for each of the following data sets, find the mean, median, and mode. And I don't expect you to do these by hand, although I think they might want you to. Basically, you would add these up and divide by the number of elements. How do you do this in the calculator? Maybe that's more interesting for you to work on. You do stat edit, and then you enter each one of these numbers in the calculator into list 1. 22.4, 24.6, and I'm going to pause while I enter these. I put in all the data. I have 13 numbers in total. And now I'm going to find the mean, median, mode, and I'm going to use the calculator to do that. Here, I'm going to find, let's see, using stat, calc, 1 var stats, enter, put in list 1. If it's not list 1, you need to put list 1, calculate. It gives me a lot of data. X bar, of course, is the mean. So let's say X bar is equal to 24.95. Normally in IB, we give 3 significant figures. So that would be 25.0 maybe. Let's see, what else? Let's go down a little bit. And, oh, there's the median. The median is 25. Okay, now what about mode? Well, the only way there would be mode here is if one of these numbers is repeated. And I'm going to check, and then I'm going to eyeball this real quick to see if there's any numbers that are repeated. So in this particular distribution, there is no mode. Okay, all these numbers are unique, and that's normally what you would expect when you have like all these decimal values, not whole numbers. Okay, moving on. Number 3. The annual salaries of 10 office workers are, and they list them here. Find the mean, median, modal salaries of this group. Explain why the mode is an unsatisfactory measure of the middle in this case, and is the median a satisfactory measure of the middle of this data set? So I'm just going to put all these numbers into the calculator, but I'm going to do something a little bit different this time because I see some repetitions. Do you see how 23,000 is repeated 1, 2, 3, 4, 5 times? Okay, so I can put this in kind of like a frequency table, and I can enter it that way in the calculator. Like for 23,000, I don't need to enter 23,000 1, 2, 3, 4, 5 times. That would be the simple way of doing it, but the quick way of doing it would be to say, hey, 23,000 has 5 occurrences. 38,000 has 2 occurrences, for example. And are any of the others repeated? And the others are all singular values. So 24,000 has 1 occurrence. 46,000 has 1 occurrence. 32,000 has 1 occurrence. So how do you enter that in the calculator? Well, you still use stat edit. And in this case, I'm going to use the columns L2 and L3. Why do I need 2 columns? Because the first column is going to be the data. And the second column, L3, is going to be the frequencies. And if I use 2 columns, I don't need to sit there repeating 23,000 5 times. I just insert 1 time, and then I go back and I say that the frequency of that number is 3. 32,000. Okay. And then I go over to this one, and I'm going to put 1, I'm going to put all the frequencies, 1, 5, 1, 2, 1. Okay, and now I'm going to do stat calc 1 bar stats for this one. And now for the list, I'm going to put the value column, which is L2. So I'm going to do second L2. And then for the frequency, I'm going to put second L3, because that's where I put the frequencies, and then I do calculate. Remember, before we left the frequency blank. So in this case, the mean is going to be 29,300. And the median is going to be 23,500. And the mode is, of course, 23,000 because it occurs 5 times, right? All right. What about B? Explain why the mode is an unsatisfactory measure of the middle in this case. Maybe to analyze this, you would look at all 3 possible measures of the center, and you see that like mode and median are very close to 23,000 because of the influence of all the people that make $23,000. But look at the average. The average is much higher. So maybe the reason why it wouldn't be a good idea to look at median or the mode as the measure of the middle is that it's just like overrepresented here. And if you look at it, it's actually the minimum salary. More people have the minimum salary, and then it kind of makes sense. It's like, oh yeah, that's why so many people have the minimum salary, because, you know, a lot of times in the company there's more entry-level people, and so that kind of makes sense that there's more 23,000. But it's not a good, even though the middle person happens to make close to 23,000, doesn't mean that that's a good middle or typical value. And so, like, maybe we'll say that the reason why it's an unsatisfactory measure is because it is the mode. The mode is 23,000, and 23,000 is not only the mode, it is also the minimum. So it'd be kind of strange to have a middle value that you'd say is the minimum. Okay. C. Is the median a satisfactory measure of the middle-list data? So this is kind of a hard one, but what I'm going to put here is that, like, do you see how all these occurrences of low salaries, like, pull the median and the mode to the far to the left toward 23,000? Well, it's like all these higher salaries, 46,000, 38,000, etc., that kind of go off to the right, they're not really represented by the number 23,500. So that's what I wrote here. Okay. Okay, moving on to number 5. A basketball team scored 43, 55, 41, and 37 points in their first 4 matches. Find the mean number of points scored for the first 4 matches. Okay, so we're just going to take 43, 55, 41, and 37, and we're going to put it in the calculator, and we're going to put it in stat edit, and we're just going to put it in the list here. We could put it in list 4, so we don't have to erase anything, and I'm going to pause while I do that. Okay, so I put those 4 numbers into list 4, then I'm going to do stat calc. I encourage you to do this a lot on your own because it's really easy to forget which buttons to press. It may seem kind of ridiculous repeating it so much, but it's worth doing, especially right before the test to review. So the mean in this case is 44. Okay. What score will the team need to shoot in the next match so that they maintain the same mean score? Well, if the mean for the first 4 games is 44, in order to maintain the exact same mean in the 5th game, they will need to shoot 44 also. Okay? If they don't shoot 44 again, it's obviously going to pull the mean up or down. So if they want to have the exact same mean, they need to shoot 44 again. The team scores only 25 points in the 5th match. Find the mean number of points scored for the 5 matches. So to do that, since we kept our data here in stat edit, all we need to do is add here 25, and then we'll do the stat calc again with 1-bar stats and L4 in here and the frequency list blank, and then we'll get the new average is 40.2. Okay. All right. The team then scores 41 points in their 6th and final match. Will this increase or decrease their previous mean score? What is the mean score for all 6 matches? You probably have done this exercise a lot in your head whenever you do your predict what your class grade is going to be. When you get a certain grade in your test, you always think, oh, if I have a 44 average and I get a 50 on the test, it's going to raise my grade. And sometimes it doesn't work out that way at EAC because we have the 70% summative, 30% formative rule, and so it kind of throws things off sometimes. Okay? So, but in this case, you can think of it like you usually do. And then so you say, okay, I have an average of 40.2, and then if I score 41, which is slightly higher than 40.2, is that going to increase? Yeah, it's going to increase. And what is the mean score for all 6 matches? So we'll go ahead and go into stat edit again, and now we're going to add 41, which is the total points in the 6th game, and then we'll do stat calc 1-bar stats. And I encourage you to do this on your own calculator several times to get used to it. So it ends up being 40.333 repeating. Okay, so that is the answer to number 2. 7. While on an Outback safari, Bill drove an average of 262 kilometers per day for a period of 12 days. How far did Bill drive in total while on safari? Okay, so if he drove 262 per day on average for 12 days, then to get the total, even though we don't know his totals per day, if we know that he drove 262 on average per day, then we can actually just do that multiplication. It'll give us the right answers. So 262 per day times 12 days, the total is going to be 3144. Okay, towards the end of the season, a netballer had played 14 matches and had thrown an average of 16.5 goals per game. In the final 2 matches of the season, she threw 21 goals and 24 goals. Find the netballer's average for the whole season. Okay, so to do this, you're going to say, okay, I'm going to add up the results for every single match. And so for the last 2 matches, you have 21 and 24. And for the first 14 matches, even though we don't know the exact score for the first 14 matches, we know that on average it was 16.5 per game. So we could just like pretend that we knew that each match was exactly 16.5 because we're going to get the exact same result as if we had the exact scores there. So we add 16.5 14 times, then we add 21, and then we add 24, and then we divide by the total number of matches, which is going to be 16, I think, because it's 14 plus 2, right? So this would simplify to 14 times 16.5 plus 21 and 24, which is 45, and I divide by 16. And that's going to give me the average for the whole season, and I'm just going to type that in the calculator here. So I typed it in here. I made very sure to put parentheses around the numerator, and if the denominator was complicated, I would put it around the denominator too, but the denominator is just one number. So the answer is 17.25 is the average. Okay? All right. Find x if all these numbers and x have a mean of 12. So how do we do that? So since we can't do that straight up in the calculator, we could just do algebra. So what are we going to have? We're going to have all these numbers, 5 plus 9 plus blah, 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 plus 17 plus x divided by, and how many numbers total are there? 1, 2, 3, 4, 5, 6, 7, 8 numbers total. And we know that that equals 12. Now we can just use algebra, right? We have all these numbers 5, 9, 11, 12, 13, 14. We just add those up, and then the rest of it's just algebra. So I'm going to add those up real quick. Okay, so I just typed in this problem, 5 plus 9 plus 11 plus 12 plus 13 plus 14 plus 17. I wonder what that is. Oh, it's 81. Okay, so our final problem is 81 plus x times 8 equals 12. I'm going to multiply both sides by 8, so I'm going to get 81 plus x equals 96, I think. Or is it, yeah, 96. Yeah. And then I'm going to subtract 81 from both sides. I'm going to get x equals 15. Okay, so x has to be 15. All right, last one. Over the complete assessment period, Aruna averaged 35 out of 40 for her math test. However, when checking her files, she could only find 7 of the 8 tests. For these, she scored blah, blah, blah. How many marks out of 40 did she score for the 8th test? So this is a similar problem. So we're going to have 29 plus 36 plus blah, 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 all the way to plus 39. And then we're going to add the unknown test, which is x. And then we divide by 8 because that's the total number of tests. And we know that that is going to be an average of 35. So this is basically the same thing. So first I'm going to do, I'm just going to take all these numbers here. I'm going to add them up on the calculator. Okay, so I just put all these numbers here and I added them up. I get 243. So the problem that we need to solve is actually 243 plus x divided by 8 equals 35. So I multiplied both sides by 8. 35 times 8 is 280. So now I have 243 plus x equals 280. I'm going to subtract 243 from both sides, which is going to give me the final answer of x equals 37. Okay? And that's it for page 3 and 4.